In this video, we're going to discuss the relationship between Q and delta H. You already know that some chemical reactions release thermal energy to the surroundings, and some chemical reactions absorb thermal energy. When a chemical reaction releases thermal energy, we say that the sign of Q is negative, or it's an exothermic reaction. If a chemical reaction absorbs thermal energy, we say the sign of Q is positive. It's an endothermic reaction. Whenever we are working at constant pressure, we refer to the thermal energy exchanged by the system and the surroundings as the enthalpy change, or as the delta H. When you perform a chemical reaction in an open beaker on a benchtop, that chemical reaction is occurring at constant pressure, as in the pressure above the reaction is atmospheric pressure the entire time. Note that not all chemical reactions occur at constant pressure. Internal combustion engines, the pressure of that oxidation reaction changes dramatically. Also geochemistry, where chemical transformations are occurring deep underneath the ground, those chemical reactions are not occurring at constant pressure. Most often in Gen Chem, we will be doing chemical reactions at constant pressure, so we can assume that the thermal energy exchanged between the system and the surroundings is the enthalpy change. Q of the reaction is equal to delta H of the reaction if the reaction occurs at constant pressure. Therefore, an exothermic reaction has a Q that has a negative sign, therefore delta H has a negative sign. For an endothermic reaction, Q has a positive sign, therefore delta H has a positive sign. Q and delta H seem identical, but there is a difference. So what is the difference between Q of the reaction and delta H of the reaction? The enthalpy of a reaction, the delta H of a reaction, is specifically the heat exchanged by a reaction when the moles of reactant or product are the same as in the balanced chemical equation. What that means is that the units for delta H of the reaction are equal to not just joules, but joules per mole of the reaction. So the delta H value is a per mole of the reaction value. In contrast, the Q of the reaction is simply the heat exchanged by a reaction involving any amount of reactant and product. So that's the heat exchanged at any point. Q of the reaction is equal to delta H of the reaction if two criteria are met. 1, that the reaction is occurring at constant pressure. 2, that stoichiometric quantities of reactant products are used.